The first question I want to ask you about how good do you know your own neighbors? And do you give them the key to your house? Basically, it is all about trust. I mean, if I develop an application, my users trust me that it's good enough, right? Let me take you into my quest from, I think it was 20 months ago, 18 to 20 months ago. And I was on a quest for buying a new car. And this is the car I bought. It's a brand new Volkswagen. It's blue, one of my favorite colors, next to purple, of course. But it was straight from the factory. And there was a reason for that, because I trusted. I trusted so much because I don't know anything about cars. Yeah, I know how combustion engine works though, but I trusted well enough that I can go from A to be without worrying that it would break down if I get into an accident, that it will keep me safe, secure, and I don't have to worry about things because it's brand new and it just came from the manufacturer. However, I could buy the same car for half the money, and then it would be like 20 years old. It would look something like this: same Volkswagen Polo in this case, blue color, but do I trust it that much? That is the big issue. I mean, I don't know the owner. I don't know the owner before that. I'm not sure what actually happened. Maybe there is a history of whatever actually happened to that car, but do I trust it enough to go from A to B and it doesn't break down on the freeway? Trust is one of the essential things. Also, if we look at the same way at software development, because just like an old car, software needs maintenance, needs every now and then you need to check up if it still works. You may need to update things. You may need to replace a few things, or in some cases, get rid of it and buy and put in new stuff. Well, let me get into that story on how software is developed, and you probably will understand where it goes wrong. Let me put in a timer just to make sure that I'm not going overdue. First of all, you and your team are creating some piece of software, a proof of concept or an MVP or however you might call it. And it probably looks something like this. It's very scoped, it's very narrow, and it does exactly what it needs to be doing. And you build it at an insane speed in a limited amount of time. So that proof of concept goes into production as a beta or whatever. And at a certain point in time, your product owner comes to you and says, like, we might need to add a feature because our customers that are using it are asking for that. And it makes a ton of sense. So that small POC will be connected to something new. And it will be looking something like this. It's still kind of in scope. It makes sense. It wasn't in the original scope, but hey, from a feature perspective, it makes sense and it still works. So it goes into production for the second time, and you go on, and then that business unit manager comes up to you and says, like, well, we found out that our users want to combine this feature with something else. And from a business point of view, this also makes sense. However, your small POC was not actually built for that. The foundation of your application was built for this small proof of concept, this small MVP. But you know how it works. There is rush. We need to set this deal like today, and it's a deal breaker. So, your team is flexible and we're agile. So we do some bits and pieces and we build something on top of something, although it's not always what we envisioned it to be. But hey, with some dirty tricks, it works. And then it happens. Then the next feature comes in, and then the next feature comes in, but you basically have no time to redo the foundation. So it will end up be something like this. You build something on top of something with something temporary, might even break something off halfway and put something on top of that. It looks weird from a technical perspective. Functionally or feature-wise, it works. But then it goes on and on and on. And you remember that one thing, they want that one application to rule them all, to talk to the moon, to fly helicopters, and you end up with something like this. If I tell you this story with the analogy of building an actual property, a building and a house, everybody's like, that doesn't make sense. but this is how we maintain our software. This is how we build software. We always put things on top of each other because, hey, we're already able to do this one thing, right? Why not build this on top? Why can't we just add a button that does X? Well, how much would you trust this building? Would you want to live in there with your kids, your family? Probably not. I'm not sure how stable that is. My name is Brian Vermeer. I'm a developer advocate for Snyk, and I'm a Java champion. So I mainly talk Java, but that's not all I do. I do some stuff in the community, but that is not really the point. Because we need to talk about a few things within our software, our life cycle. And one of the things is the stuff we rely on, we trust, and we depend on. That's why they called dependencies. I will take an example from the Java world. And if you're a Java developer, you might have seen this. This is the Spring Boot initializer. The Spring Boot initializer is a marvelous thing because you can just scaffold an application and put in some of the dependencies you need by clicking on it and making sure that it works or that it's there. And automatically it will scaffold an application for you that starts up and that basically works. You have to implement the features that you actually want yourself, but it is an application with dependencies for security or for creating webhooks or whatever is there in there. But let me take a larger look at it. Let me zoom in on that one. Say that this is the application you create. So this is the jar file. It will be an executable jar. And say that jar file is like this big. How much of that jar file will be the code that you wrote? Like in the end, the one that you put in production, how much is the code that you wrote? It's probably something like this. So it's a very, very small amount. And we take good care of that small amount because we probably have code reviews, we have pair programming, we look at security problems because of these code reviews, but that's just like 10%-ish or less. How about the larger scale? How about the larger yellow bowl in this image? And if you look at it, and I found a picture on the internet like the other day, and it's a bit like this because we trust what we pull in. But if I pull in a framework or a library, it pulls in something else underneath or something else underneath that, and so forth and so forth. And it might be something like this. Like from the top off, it looks like a brand new thing with all modern stuff that you want to have. Only deep down below, because dependencies depend on dependencies, depending on dependencies. There might be this one dependency that just is maintained by one single person in Nebraska. And what happens if I accidentally run over this person with my new blue Volkswagen Polo? What if there was a security problem in that package? What is your single point of failure here? Well, that actual package. And that can be a normal bug, but more importantly, it can also be a security issue. I wrote a tweet about this like a year ago, and I actually did an experiment, and it was something like this. I scaffolded this Spring Boot application, and I wrote 4 lines of code. And the 4 lines of code were basically a hello world. This Spring Boot application scaffolds an application together with a web server basically included in that. And it's overkill, definitely. You don't need a full Spring Boot application to just print hello world. But I ended up writing 4 lines of code, having 33 dependencies or 33 jars in my application. So that were dependencies and the dependencies. And in the end, it was over 50,000 lines of code, 500,000 lines of code. So pulling in dependencies means that you depend on somebody else's stuff and you're not only responsible for the stuff that you wrote. And you probably take good care of that and you do code reviews on that. But what about the rest? Are you actually looking at that? If you want to know more about this experiment, I wrote a blog post around it, and I explained what I did, how I did it, how I came through these numbers. But it's an interesting way of thinking about it. So let's look into your dependencies and why you should be careful when you pick them, maintain them, use them. And I will explain it to you in basically 3 steps. Let's go to step 1, how to pick your dependencies. So step 1 is basically on the far, in my case, the far right. The first thing you need to do is how good is that package? Interestingly enough, there are a ton of packages in every ecosystem, and you want to pick the best package. And is the best package the one that works, or isn't it? Well, let me give you some pointers to look at a package. First of all, does it solve your problem? And interestingly enough, that sounds obvious, but sometimes it's not. It's just, the package doesn't solve the whole problem, but just partially the problem. You need another package and another package altogether to solve the actual problem what you need. Is it worth to put in that package, or do you need to search a bit further to actual package that solves the complete problem? Secondly, do I actually need that package? Well, in previous session, in the APJ time zone, we already talked about encryption. So if you want to do encryption, yes, you need that package and you don't want to write it yourself. But say it's a very large package that does all sorts of string manipulation, and you only need one tiny function of it. Do you actually want to pull in that package? Because what comes with that package, what is underneath that package, or what is underneath that dependency that you pull in? Or is it easier to write that thing yourself? How many contributors are there? Say in the point, there is an issue with it. And in this case, a security issue with it, and you want it to get solved. If there is just one maintainer, like that person in Nebraska, and that person is not available, you're screwed, basically. Or you need to dedicate time in yourself. So that is a decision you need to make. Do you want to use that package? Do you want to put effort in it yourself? Which is by far the best thing to do, in my opinion, or to put effort in yourself, not to pick that package, but to put effort in yourself and contribute to open source. But it is a liability. And last but not least, is it still maintained? I mean, there can be many contributors, but is it actually actively maintained? When was the last time that actually released a new version? Well, we can do some research on these things, right? We can look if these things are actually going. So if I do that for a Java package, for instance, I look on Google and I come to the Maven repository. And for instance, I do this for the Eclipse collections framework. And well, I can say like, hey, it's actively maintained. The last release was in November 2021. So yeah, tick that box. I can do some research and look if that framework or that collections library is actually heavily maintained. So I can go into the GitHub repository and see if these things are maintained. And you see that the last request was like a few hours ago, 11 hours ago. But I can also look over here if there are any pull requests, if there are known issues, if there are known issues that people are actively solving, or maybe there is a security issue in here that is already lying around for a year. So this is an interesting line of thinking, like, do I need to pick this package? And then secondly, do I need all of it? I mean, this is a package containing a ton of collections, but it's 9.9 megabytes. And if I'm just using one of these things, do I actually want the whole package? Or do I just put some code, duplicate some code in it, and use that single line or that single collection that I need? Do I want all of this? What comes with it together? One of the things you can use, of course, I did this for a Java package. You can look at all the individual things, but there's also a website called the Advisor. That, for instance, this is the Express package in JavaScript, and it shows you what the package health is, gives you a score, and looks at the popularity of the package, how it's maintained, and if there are security vulnerabilities. So this is a helpful thing to pick your package and to see if that package is actually suitable for you. So, okay, we picked that package. That package over here, we picked it, and then we're done, right? Well, it depends how old your car is or your application is, because at some points in time, you update. And when do you update? Are you that person like that is on a machine and say, well, I update tomorrow. I do this later. But if you keep updating later, tomorrow, the day after, the gap between the old version and the new version is getting bigger and bigger and bigger. But what about updating? So we had picking. Now we need to update. We need to maintain it. It's still alive. If we look at dependencies, we basically have to reiterate what we did. Like, are there regular releases? What are the indirect dependencies, and do they have issues? So we have to look a little bit deeper than just pulling this one in, putting it in your manifest file and saying like, it works, fine, ship it. Keeping track of this dependency health and if there are regular commits keeps you in charge of what's actually going on. If you see that regular commits stay out, like it used to be okay, but at a certain point in time, you see that it's basically dying, that might be a good pointer for you to say, hey, maybe we need to migrate to something else. Because if something is not maintained, eventually somebody comes up and finds a security issue in that. And again, it's not what you want. How do we keep track of this? Do I manually look at all the websites and it? Well, your package manager can help you with that. If you're working with Maven, you can do something like Maven version display dependency updates. I did this for a Maven project I run, and this is the output. So it basically says to me, like, I have 5 dependencies, and all these dependencies have new versions. And I can choose if I want to update to that version. And remember that if you see the first line, you see the com.h2 database, you see that is just a minor update. So probably if I just take that minor update, it's quite okay. However, you see that in some cases, it's already a bigger update. It's a major update from the 10 version to the 11 version of Eclipse Collections, for instance. Remember that if my package manager can already help me with it, I can automate this. I can automate this in my build cycle, and I have a report every time we go out and see like which ones I can update. And if we make that delta between the old and the new version small, that means if there is a problem and we need to upgrade because of a security issue, probably it is not that big of a deal. But if you make that delta as big as possible, you might not just need to update one dependency, but need to update several dependencies because they might not work even together. If you work, for instance, with Gradle, you can use the dependency update plugin. And for Maven, you can install for Maven for npm, you can install npm check update and do NCU. And for npm, it looks something like this. And here you see that for a couple of these dependencies in my application, it's already quite a big step. And if I update one of them, I might need to update more of them, and it breaks API, and it costs me a lot of time, or there are already security issues in there. And I talked a lot about security issues. So are there any issues with my dependencies? Well, we know for a fact that every year new dependencies or new vulnerabilities will get found in your dependencies. If we look at the vulnerabilities identified in different ecosystems over time, we see that in this case, my beloved Maven or Maven Central is the clear winner. However, luckily it went down between 2018 and 2019, but it's on top of what's already there. So if I'm like way back into an application that is already running for several years and I didn't look at it, it might be, there is a great chance that there is a vulnerability in that. And I already told you that libraries bring in libraries. So looking at, for instance, NPM and Maven, it's not so much the package that you pull in, but the package that implicitly comes in because you pull in that package. Hope you still get me. The layering, right? Several layers deep, maybe 5 layers deep. There is a marshalling library that you don't want to have because it has an arbitrary code execution issue. Well, in this case, I can scan with tooling to see if these vulnerabilities are there. And I'm not going into the tooling. I used, of course, the Snyk tooling in this case. But in that NPM, in the Node.js application, I scanned and I found a bunch of vulnerabilities. And I want to light out this one, the marked library. And the marked library that I used was super old, like 0.35. And luckily it says to me like, hey, you can update it to 1.1.1. Okay, that might be a problem because it's a major update, but I want to pick up one of these vulnerabilities that is found, and that's this one, the last one. If I look at this vulnerability, and I go to that URL that you can see, you will see that this is a typical cross-site scripting. Well, not so typical, but it's a cross-site scripting error. And what we found out is that it's not so much a problem of the marked library, but the combination of the marked library and the intelligence of your browser. Because I wanted to do a JavaScript alert or a JavaScript cross-site scripting, and I used HTML encoding to obfuscate a few things. And basically, this was sanitized by the library. However, if I put in a keyword like document or this, which doesn't make sense. My browser says like, well, you probably mean something else, omits it, but it goes through the sanitization process, and actually the cross-site scripting works. So you can argue if it's a marked problem or a problem with your browser, or basically a combination of the two. But the point is, it is an issue in your application, or in my application in this case. If we look at what happened, and we can pull up the pull request, we see this. Somebody found this out, somebody put a pull request in. But take a look at the date of this pull request. That was May 19th, 2015. So somebody found out. You can argue if this is responsible disclosure or not, but somebody found out, put a pull request, public pull request, and actually fixed it for the maintainer. However, this was eventually merged. And I emphasize eventually because this is the date. So you see that for a year, this was out in the open, it was published, but it was not yet merged. So everybody was vulnerable for this one. So it's not only checking what the problem is, but also, hey, are there any issues with this library? Or maybe this was a good reason to move over to another library. Got me? So we had step 1 was picking, step 2 was maintaining. Let's go to step 3. And step 3 is removing. And when do you remove? When you're out of disk space? Probably not the best way. I worked as a consultant before joining Snyk, and I worked for several companies. One of the companies I worked for, I found this. This is a manifest file for Maven, a Maven pump file, and this is line 977 to 1023. This is just a very tiny snippet because there were all dependencies in there. And we can argue about if they were maintained or not, but the thing was there are so many dependencies that basically once a dependency gets in, it never gets out. I found 3 different libraries that do the same thing, 3 different XML parsing libraries. And does that make sense? Because in this case, for this ecosystem, anything that is available in the class bot can technically be lifted to memory and can actually be used. So if you think of a security problem as a chain of problems or a chain of attacks, it's not a direct attack, but somebody finds a starting point and connects a few things to each other. These outdated libraries that you're not using might be an issue for you. Again, luckily your package managers can help you with that. For instance, I want to analyze my dependencies and I want to ignore every non-compile dependency in Maven. And I can do this with this line, and it gives me something like this. Like, hey, you included the Apache Commons library, but you're not referring to it. So that would give me a pointer, like I have to investigate, and maybe I can lift or I can get that one out of my application. So it's not packaged with that application, and it cannot harm me anymore. Same you can do for Gradle, but there is no native plugin as far as I know. Maybe there is now, but one of the plugins you can use is Nebula plugin. And of course, for NPM, there's something like DepCheck. And with DepCheck, it gives you a list of things like, hey, these are some unused dependencies in your application. And if you see they're not used, you might want to investigate if you just want to move them out of your system. So if you want to go through your dependencies, the dependencies are a large portion of your application. You need to do 3 things. You need to be aware of these 3 steps: picking, updating, and removing. From the beginning, the middle, and in some case, you need to dispose them. So let me recap quickly what you need to do to have a good dependency strategy to make sure that the health of your application, and included in that, the security of your application, isn't harmed by the stuff that you just pull in. First of all, include only for a good reason. So when you pick a dependency, only include it for a good reason, not because there's this nifty one function that I can use, but it brings you in a ton of stuff that you don't need. Check your dependency health when you pick it, but also at maintenance level. You need to do that over and over again, or at least a certain amount of times. Every time when you want to release, for instance, check if the dependency health is still okay. or every week or every month, but you need to put this into your strategy. Scan your dependencies for security issues when you pick, because you don't want to pick a dependency that is already insecure, but also security vulnerabilities will be found over time. So you need to do that in that maintenance cycle as well. Update often to newer versions in your update cycle, because if you update to newer versions and these are minor releases, that'd be a good way of keeping track of the things. And you might need to do some rework, but then the rework is just small. If you wait, the rework will get bigger and bigger and bigger and bigger, and then at the end you have a problem, and you cannot just fix it by inserting a new dependency or a new version of a dependency, but you need to rework your whole system. Please remove unused dependencies. Take that Boy Scouting rule. If you don't need it, get rid of it. I'm not keeping a flat tire in my new or in my car because for the sake of having it. If that tire is done, I'm not using it anymore, dispose it. And please use a ton of automation to help you with that. You saw that the package managers can help you with that. Connecting your Git repo to tools like, well, Snyk or any other tools can help you with scanning, with maintaining, and automatic pull requests and that kind of stuff. In the end, we want to be sure that we can trust our application just as much as I can trust my brand new car. I can drive in it, it gets me from A to B, and without any worries, I keep it going. But a year from now, I probably need to go to the workplace to make sure that it's still okay. If there are any questions, feel free to ask them and deploy me to them. Thank you for your attention.
Wow, what a great session, Brian.
Way to kick it off there, Brian. I mean, I do have to comment about your incredible taste of cars. I use that term very, very lightly there. So something that I found really interesting in your talk actually was about the fact that one of the rules was don't have any packages that you don't need. Do you feel like there's an inherent pressure for people to sort of load their applications with packages because they feel like they should, or because other people have maybe recommended it to? Is that something that you've seen quite a lot?
Well, I think it's the other way around, because people are working on it and they use the package, but they found out there is something else that they can use in a better way. But they removed the code, but they didn't remove the dependency. So that dependency is just a legacy dependency that is not used anymore. It maybe was used in time or some time ago, but it's not used anymore. And they might get rid of the code, so take care of that own code, but the dependency is still there and can still harm you. And people are not aware of that these things can harm you even if you're not directly using them.
Okay, so your recommendation is make sure you clear the decks fully rather than just sort of doing what you need to and then just leaving the rest and hoping that it'll just fade away.
Yeah, do what you need to. That sounds great, but at a certain point in time, you probably have bits and pieces that you're not using anymore. Why do you keep the stuff that you're not using anymore? It can only hurt you.
Yeah, no, that makes absolute sense. Brian, thank you so much. Ooh, we've actually got another question, actually, very quickly. We can try and bring that up. So the question is, how do you automate the minor versions dependency updates? Do you do it through the CI?
That is up to you. That depends on how the context is of how you develop. If you have a CI pipeline, yes, you can automate that. For instance, it's a bit of a product thingy, but if you connect your Git repository to Snyk, we can do these kind of things for you, as in we can create pull requests with newer versions for that, and you just have to click accept. But that might not be the way you want to do that. You have the information, and most of the times the information is key. So you know what you need to do, and you can create custom integrations for that. Or you can say, like, I want to manually do this because then I'm in charge of, hey, I'm not sure if my test will cover it. But the point is, you need to know before you can act. So that's why I wanted to point out, like, do the automation at least on the reporting, that you know that there are newer versions on it, and that you can manually do that on your local system to see if, hey, it works. Okay, now I can upload it to my Git repository, for instance, like that.
Perfect. Excellent. Thank you so much there, Brian. Cool. So we would like to love you and leave you, and we'll actually have you up on stage very soon to come host with us because we love to delegate.
Obviously, if anyone else has any question for Brian when they're rewatching this episode or a bit later, feel free to hop in anytime during today, and then on the Slack community afterwards. But yeah, who is up next? Thanks so much, Brian. We'll see you on stage in a second.